Hello, everyone. Welcome back. I hope you're all having a wonderful day. Welcome. Welcome back to workshop 2 of this week. It's week 2 of the EigenLayer Hackathon with Encode Club. Today we have Altan, who will be joining us, and he's going to be talking about the Unified Fast Finality. Near's Unified Fast Finality. I will let Altan introduce this himself, but good to see you all. If you're all here as well, I've dropped the slides in the chat. So if you want to follow along, please look there. And if you've just joined us, please feel free to give a little GM in the chat and show us that you're all here.
Awesome.
How are you, Altan?
Good. How are you? Are you able to hear me?
Yes, perfect. All good, and we can see your slides as well.
Awesome. Cool. Thanks for everyone for being here. It's great to contribute to something that Encode does and something that EigenLayer does. Because Encode, just for context, I think I was doing the hackathons and workshops pretty much like 2 years ago when I graduated. So that was quite fun. And EigenLayer is something I'm super excited about. It's something that wasn't available when Near was started, and now it is amazing to be able to bootstrap security from existing Ethereum validators. So just to give you guys a bit of a context, so I used to be at the Near Foundation. This is quite a bit of alpha. So Nuffle Labs is a new entity that we're creating that pretty much does like the focus on Near's modular solutions. And I'll basically go through them because they all, the first one's NearDA, and then the AVS is built up on top of the NearDA. So, and then we can go and deep dive into how does that look like in practice and what are the use cases that you can build up on top of, or just to give you guys a bit of an idea what an AVS could look like. As I said before, we're the builder and amplifier of Near's modular product suite. So we have 2 core products, which is NearDA and Near Fast Finality Layer. They're mainly targeted towards scaling and expanding the Ethereum ecosystem with Near's core primitives alongside with EigenLayer Security. So just a bit of a context here is that like when Near was started, Near actually wanted to contribute, Ilya and Alex, for the founders, wanted to contribute to the sharding roadmap of Ethereum, basically Ethereum 2.0, but they basically weren't able to move as fast as they wanted to, so they wanted to launch their own blockchain. So it has its like interesting primitives and interesting sort of like the sharding design that allows that is quite unique and applicable to the basically Ethereum's scaling roadmap. Now, if you look at these products, the first one is NearDA. NearDA is technically just a smart contract that's built on Near. It is linearly scalable data availability solution because it could just scale as you add more shards. So Near has currently 6 shards. Then every shard is actually like 4 megabytes per second. So it could go up to even today, like 24 megabytes per second of data that you can push through Near protocol. That means basically data being validated by the Near chain's validator set. So we started that as kind of like, hey, use this for like Near protocol security to provide data availability for ETH rollups. But when we met Shuram last year, we actually realized, okay, like we have fast finality on Near and we have this DA thing on Near. So how do we kind of like provide something a bit more, almost like a DA++, where we can do more with the data availability that we offer on Near protocol? So we decided, let's just build a new layer where you can actually prove state across L2s, right? And the idea of this is like basically an aggregation layer where you can see the state of any rollup that participates in this network. So it could be like OP's mainnet state and ARB's mainnet state. This is important because when you have that layer, you can actually start building cross-chain applications on top of it. And I'll talk about what applications it unlocks at the end of the presentation. Now, if we go back to 2020, when Near was launched, Near launched as a sort of a monolithic L1, meaning blockchains do 4 core things, it executes the transactions, meaning like, it says, hey, I'm going to do this action. And it also has like a data availability layer where you can actually store some of the data of those transactions and allow other validators to come in and sort of like let them validate those transactions. And the settlement layer, when people talk about this, like basically the finalization of all these actions together, and consensus, as you know, like being able to just say everybody agreeing on the state of that blockchain. Now, when we are moving towards Nuff protocol, which is more modular, the way we see this is kind of like, you have Ethereum L2s that are, OP, whatever your best L2 is. And then you have the Ethereum L1, which has accumulated a lot of sort of cryptoeconomic security. And, we have this NFFL EigenLayer AVS, which uses NearDA to provide sort of like a state aggregation. And NFFL EigenLayer AVS just doesn't have to be eventually, it will evolve not to be for L2s, but really using EigenLayer to provide sort of like state attestations for any blockchain that you can think of. Now, Nuff protocol is an evolution of this, right? So basically, NFFL EigenLayer AVS is kind of the first AVS that we're building, but eventually you should be able to leverage Nuff protocol to build any AVS that you want that is in the side of like chain, sort of chain abstraction and sort of like a cross-chain application space. Now, if we want to sort of like look at NearDA, it's important to understand how NearDA works, to understand how the AVS works. Essentially, what it does is, let's assume there's an L2. Let's assume this is an OP stack L2. So there's three important components of that L2. So you have a rollup node, which is just an execution client. You have a batcher and a proposer. The job of a batcher is basically publish the transaction ordering from the seed queries to NearDA. And the proposer is basically submits the near commitment data to Ethereum. So what this allows us to do is pretty much rollups use NearDA on the Near blockchain and then get an inclusion proof on Ethereum L1 to say, hey, these transactions happen, thus this L2 actually used, basically data availability went through Near. Now, if we think about EigenLayer, well, when Near was started, you had to sort of like create your own validator set, right? Meaning you go to a bunch of different staking providers, you give them sort of a token allocation, you say, hey, you're going to take, I don't know, like 500K, whatever token that you want, and you should be running this sort of validator to get some rewards, right? So basically people kind of like had to bootstrap a new validator set to build a new blockchain or any other decentralized service that they want to build. I actually took one quote from EigenLayer's white paper, which the interesting thing about this is like, everyone can build their own trusted networks using sort of the EigenLayer security and the restaking model. And then, they can just create and implement a new distributed validation modules, which we say like actively validated services. I'll explain that later what that means. But over time, we built NearDA as an on-chain primitive, but now we basically take NearDA and then EigenLayer offers us a new path where we can actually do useful compute that could be done with off-chain and have some on-chain security from Ethereum. Now, why do we build this NFFL thing? Well, modularity is great. Like you can use the best components from all the other different blockchains. You can use data available from EigenDA, Near, whatever you want to do. You can use an execution layer that's, EVM, even SVM now, or MoveVM. But it creates problems because now if you go to L2 beats, you have like 100 different L2s. You have different, obviously L2s are ones, and now we'll probably start seeing like modular L1s. In that world, there's really three problems that we see that are quite important. So the first one is fragmentation. Obviously, the fragmentation of liquidity, which is essentially crypto is a big market, right? If you think about like 2 to 3 trillion economic value, but still if you compare it to traditional markets, it's very small. And we're taking that and fragmenting that even to very, very like little components, and you end up with, I'll show you later, is you end up with almost like 18 billion TVL security on Arbitrum, and then the rest is kind of like not even secure enough. Which comes to the next point of like terrible UX, right? If you're trying to use a bridge today, or if you're trying to use a cross-chain application, the user experience is quite tough. And like if you give it to your grandma or mother, like they're not going to be able to use this thing, which essentially is a problem that Near ecosystem as a whole has been sort of attacking. And the third part is terrible security. Obviously, you have all these different chains. They have all different validator sets themselves. And there's these problems with like chain reorgs and forks. So creates this like almost terrible consensus security in a way. Now, fragmentation, if you look at just literally the top 10 of L2s, you have obviously almost $60, $70 billion sort of stake on Ethereum, but now you go to L2s, they start with 18.7 and they go below 1 billion after number 7. And it's terrible UX. Obviously, I love to give this example of Osmosis. I love Cosmos as an ecosystem, but when I first used Osmosis, it was really hard for me to kind of like move assets between. For example, I didn't understand the fact that if I have, let's say, USDC on Axelar or like a TIA on one chain, it was really hard for me to figure out where to send the money. So this is just because it's fragmentation, like fragmenting all this liquidity, which Cosmos is a great example, and then it's really hard to navigate with the user experience. And obviously terrible security, right? So as I said, consensus faults are a big problem. And this is also a huge problem because when you're building sort of multi-chain applications, you don't know which sort of when the chain forks, like you need to wait for the social consensus of that protocol to kind of figure that out. And it becomes a bit of a problem if you've done one action on LL1 and so L2, and then you want to push that, build a bridge or whatever you want to do, it becomes a bit of a problem. So that comes to the main sort of this things like near DA is just not enough. That comes from a Nuffle Labs joke, by the way. Near DA solves the DA problem, but it's not worlds enough for solve the fragmentation, terrible UX, and terrible security. Bridges kind of solve this problem a little bit, but they're generally not secure. They're quite fast, but with EigenLayer you can actually build faster primitives that I can explain later. And yeah, so coming to the main point is like chain abstraction is not enough, right? So our vision is that users should be able to interact with different blockchains seamlessly while also getting security guarantees if something in consensus goes wrong. And current products, Wormhole, make these transfers possible in a fast manner, but security is usually centralized. For example, if you go to Wormhole, there's 21 guardians that actually sort of like facilitate the transfers between a blockchain to another one. So NFFL, what is this, right? Basically, it is a fast and secure settlement layer that is an EigenLayer AVS. NFFL basically uses like Near's tech stack and EigenLayer's tech stack to provide a bit of an interoperability primitive by verifying state attestation secured by restaked ETH, right? So this is a lot of jargon here, but essentially what we do is we prove all the L2 state and give that back to the developer to build stuff with it. And the quite unique thing is, well, this is done quite fast. You can actually achieve sort of the state finality in 3 to 4 seconds. And that allows you to sort of like do applications almost like natively. For example, a cross-chain app, if you want to do a cross-chain DEX, if you want to do a cross-chain lending platform, NFFL allows you to do that. Now, I'll talk about with a lot of EigenLayer jargon. I know this is the second workshop, so love to break it down what these are. Liquid staking tokens are very fairly and widely used in the Ethereum ecosystem. They're just representation of a staked asset, right? So you basically lock that asset, you stake it in Ethereum, and you get that sort of liquid staking token. In staked assets, we talk about it about like you can stake an asset and you can use native ETH or LSDs to back and almost like any productive work in EigenLayer. You also have these like actively validated services. I talked about them a lot, but it is just a system that some sort of like needs security to do something, to some like productive work, right? So in our case, we're doing this productive work of almost like aggregating state, but there's great examples of EigenDA, which creates a data availability layer using EigenLayer restaked ETH, and also oracles and other ones that if you go to Holsky, the testnet, you can actually find these examples of many AVSs, and I'm pretty sure this is going to be a boom of AVSs in the next year. So operator, what do? They basically take stakers. So they take the ETH from the stakers, restakers actually, and they opt in to do something for the actively validated services, right? So operators could be anyone. Like there's tons of operators that come in and opt in and do productive work. And finally, I use the aggregator term a lot here. What aggregator term does is essentially, in our case, and I think EigenDA does this as well, or even the incredibly, I think that there's one example from EigenLayer that does that. Essentially, aggregator is a place where you gather signatures from different operators, and you have a consensus on those signatures, which is basically aggregating all that signature and using a method called BLS aggregation. So it kind of simplifies all these signatures and allows us to do something with it. Now, what are the components, right? So there's 4 components. This is actually really modular system. Well, you have Ethereum, which is the L1, right? You have the SFFL AVS smart contract set, which essentially interacts with all the EigenLayer core contracts that you probably have learned if you if anybody talked about them in workshop 1. In Near, you have a DA smart contract for each of the rollup that participates in this sort of fast finality layer. And then on rollups, you have a SSFL verifier smart contract. Their job is to just check network state attestations from the aggregator itself. And finally, basically off-chain parts that are quite related to EigenLayer, the operator I talked about, and the aggregator as well. Now, NFFL Design. Now, took all of it and put it into schema. I'll walk through how this works one by one, starting from Ethereum. Yeah, this is quite. We've never seen something like this in crypto, where you use two L1s to do something different, and you have restaking, which allows you to do sort of amazing kind of like work that allows other networks to build the applications to build almost cross-chain applications. Now, let's talk about Ethereum, right? So restakers, as we talked before, they are pretty much the users that take restake their capital to EigenLayer contracts. So if you can see it here, and obviously NFFL has a contract on Ethereum that EigenLayer usually refers to as middleware. The job of a middleware is to facilitate the interaction between sort of like the on-chain components, like the EigenLayer core, with the off-chain components, which are the operator and the aggregator itself. Now, let's leave that all Ethereum side aside. Let's assume there's just a bunch of different networks, and we use NearDA pretty much as a sidecar product, meaning sidecar here says, I'm not going to change any of the core architecture of the network. I'm just going to look at the sequencer, which is for sequencer for L2s is essentially it's usually centralized, hopefully decentralized in the future, that gives the sort of the transaction ordering of that L2. And there's a relayer that takes that sequence and pretty much dumps it on a contract on Near. This is quite unique because it's really hard to change, for example, for OP, Arbitrum, all of these, to go and ask and say, hey, change your sequencer architecture. So rather what we do is just look at their data and dump it onto Near. And then essentially there's just many operators that live in the system that run an indexer to acquire the data from NearDA and compare that. So they run a full node of let's say OP and ARB, and they basically prove that the data is correct, right? So we were both looking at the data availability and looking at the full node. We're able to say, hey, both of those are correct, and now I'm attesting to the state that the state is actually correct. And by the way, this is just not one operator, right? So there's a bunch of different operators that come in and go that do the same work. And yeah, so basically they sign the message, and then the cool thing about this is now when we sign all of these, we have the aggregator to have an API. This is still being built from our side for applications to come in and use that, right? So I'll give an example how you can use it to build a protocol, but this gives all the L2 state, right? So you have the state of an, let's say, OP, ARB, all of them, and you can build cross-chain applications saying something happened on OP, and I'm going to do something on ARB. So NFFL in practice, how does this look like? Let's just assume like there's a hello protocol, right? It's very simple. I want to send a message from network 2 to network 1, say that I'm sending in hello message. So what would happen is we would do some events on network 2, and this would cause a change of the state of the network 2, right? Operators, obviously, since they run a full node and they also look at the near DA and take that data, see this change and attest to this change and making it available through an API to the aggregator. Now, Hello Protocol, which is an application, it could be any, this is basically a product that's facing developers that takes that state of network 2 and says, listens to events from network 2 and takes that state and says, does something on network 1 saying, hey, hello message has been passed from network 2. Now, application can do whatever with this hello protocol. They can just even print or whatever they want to do. But essentially now you have done a message that's sent from network 2 to network 1, just using sort of this EigenLayer security model, which is quite unique. And what are the possible applications? Well, you can design cross-chain DEXs, right? So this is one of these things that are quite exciting for me. Historically, you had to go through Binance, any centralized exchange to build a cross-chain exchange. Now you can just basically build a cross-chain DEX that uses 2 L2s, and you can buy, let's say you have USDC on an Arbitrum, and you want to buy, let's say, any USDT on OP. You can do this interaction in 3-4 seconds in a very simple way. You can do a cross-chain lending platform. You have some, let's say, you lock some funds on OP, and you want to take that and do something on ARB. You can pretty much design these systems, which is what I'm excited about. Actually, like let's say you have your lens profile on the last network, which has been announced recently. You can use your lens profile to do something else on any other L2. Obviously, the main sort of easy use case that you think about is bridges, right? So lock funds there, here, and there, so you can actually like design this bridge. And literally, you can do anything that can combine 2 or more different blockchain states. So I'm pretty sure there are other folks that are more creative than me, but these are the things that I can think about from like DeFi and SocialFi perspective that are quite exciting. And yeah, so connect with us. Pretty much, I've dropped my Twitter and Telegram, and we're actually just sort of like spinning off from the Near Foundation and did a fundraise. So we'll announce that very soon as well.
Awesome. Thank you so much, Altan. Amazing presentation, really, really well summed up. And yeah, a little bit of alpha for everyone in the audience. I do believe there are a couple of questions in the chat. So if you have the time to, please, please have a look at those. Do we have you for another few minutes?
Yeah, I can stay for 5 minutes. Yeah.
Awesome, absolutely. Cool, so I think we have a couple of questions in the chat from AJ and everyone else. If you guys have questions, now is the best time to kind of ask those. We've only got a few more minutes left of this workshop, so please drop your questions in the chat.
Yeah, so one question, does NFFL work with other L1s? You can design it that way. Essentially, rather than look, I mean, every L1 has a sequence of transactions that's been blocked. So rather than looking at a sequence of an L2, you can look at that sort of like transaction ordering and dump it somewhere, like near DA, EigenDA, whatever. And then you can still provide a state of that. So it could be generalized, but the current design has been fully focused on L2s. And there's this other sort of question, which is how is this different than Layer 0? Well, Layer 0 is just a general messaging platform. It doesn't use any of the security model of Ethereum. So NFFL predominantly does something similar, right? But it uses EigenLayer Security with Ethereum Security. So that's number one. And number two is we're actually working towards more on how do we do sort of like insurance if something happens on other L2. So insurance in the sense of like consensus insurance. So what if chain reorgs? What if there's a fork? Yeah, so those are the main ones pretty much. Like, how do you ensure that if something happens, I can still back that transaction with some collateral? So that's something we're working on. Is it ready to build on this hackathon? So not really, because we don't have the API set up yet. It's very new. We went to testnet, but just wanted to give a bit of an idea, running how to build an AVS, like knowing some of the stuff that we have done that on Near, and then how do we kind of apply that to this new paradigm.
Awesome, cool. I don't believe there are any other questions, so I'll take these final few minutes to wrap up. But thank you so much, Altan. Yeah, it's a really great bit of tech that you're sharing with us. Really fun to get a bit of alpha before it's fully released. So everyone in the audience, please do watch out for all of the updates that come up. Yeah, I think that is pretty much it. To everyone else, our next workshop will be tomorrow with Gajesh, and same time. The link will be in your calendar. I will be posting it as well. But thank you all so much for coming. Thank you so much, Altan, for tuning in. I know you're in Berlin right now. It's busy. It seems like a lot of fun. But yeah, any final words?
Thanks.
No problem.
Thank you so much. Yeah, it's been fun. I know I've been trying to. There's a lot of technical concepts, but eventually, when you start to learn EigenLayer and how the EigenLayer core contracts work, and you'll start to kind of figure out and learn how to build AVSs. I mean, that's kind of the fun part.
Yeah,
cool.
Absolutely.
Great.
Cool.
Thanks, Angela. Thanks, everyone. Have a good one.
Thanks so much. Bye.